Okay, good afternoon. On the behalf of the Astrobiology Online Organizing Committee, I would like to welcome all of you to our last and fourth lecture of the 2021 edition of Astrobiology Online. And I'm really very happy to welcome Dr. Janet Siffert. She has been a very staunch supporter of our astrobiological community in Brazil. Actually, her contribution goes a long way back in 2006, when we organized one of the first really big meetings trying to organize the Brazilian astronomical community. And she was there supporting us. We had pre-resources. We didn't know exactly what to do. And we have come a long way. And part of our success is due to Dr. Janet Siffert's contribution to our community. So again, thank you very much, Janet. So let me introduce now Dr. Janet for our lecture. Dr. Janet Siffert received her PhD from the University of Houston and is an associate research professor in the Department of Statistics at Rice University since 1998. She is an origin of life researcher who received her training from Dr. George E. Fox, co-discoverer of the third domain of life. She has renewed work on the understanding life's origins through microbial ecology and genomic and metabolic evolution, being the first woman to serve as chairman of the Gordon Research Conference on the Origin of Life and the first female president of the ISO, International Astrobiology Society. She's a member of the University of Washington's Virtual Planets Laboratory and was recognized as an astrobiology pioneer. So we're really happy to have you again, Janet, for our Astrobiology Online meeting. So thank you, and you have the floor.
Well, it's my pleasure to be here. So thank you so much for including me. I am a big supporter of the Brazilian astrobiology community. So today, despite that wonderful introduction, I'm not going to talk to you about molecular evolution, or I'm actually going to try to talk about something that I hope will inspire you. Because there are big changes. The pandemic is not the only thing that has changed the way we are living these days. So the title of my talk is Space Explorers, the Future of Astrobiology. So the first thing, this is difficult, I'm sure, for everybody that's listening. I have no idea who you are, but I'm going to take a guess that if you're here and you're interested and you consider yourself an astrobiologist, you could be a geologist, you could be a biologist, climate scientist or an astronomer, computer scientist, or perhaps an engineer. What that points up is that astrobiology is a multidisciplinary effort that brings a lot of different disciplines to the fore and actually allows us a chance to speak with each other about a very difficult problem. So as astrobiologists, what have we usually done in the past? Well, we've investigated evolution. We've looked for life elsewhere. I do believe you've had, maybe the talk this morning was about evolution. We look for life elsewhere. The astronomers, that's usually what they're doing. We've looked at extrasolar planet discovery. I think Jim Casting probably went over that pretty well yesterday. We look at climate models to understand, to inform what we think might be happening on other planets. We look at geological processes. The problem is, or what I think could be happening, and what I hope is happening, is that maybe our jobs are getting ready to change. Now, most of the time, those of us in the US, we are kind of US-centric because that's where we live. So forgive me if this particular video that I'm going to show you is somehow inappropriate. Since I don't speak Portuguese, I have no clue what they're saying, but I'm trying to get a point across here.
Hindi ka na daw teacher, hindi ka na rin weather forecaster. So what are you now? Superhero? Now I'm a fortune teller.
All right, so what he said was he's a fortune teller. So unfortunately, I'm stepping out of the molecular evolution, and I'm hoping I'm going to foretell the future a little bit, but I hope it's actually impactful for you as Brazilian astrobiologists. So let's see what astrobiologists have usually done. And I think a couple of talks have already gone over this. Of course, this is the beautiful Milky Way. This is a shot from the moon looking at the Earth. And if anybody's seen this picture, I fall in love with this picture because this is Cassini taking a picture looking through Saturn's rings, looking at the Earth as it flew by. So what this shows us is just how much we have tried to reach out into space to understand our local solar system and even beyond. So I think one of the best people who have encapsulated this interest in space and our astrobiology focus is, because we are creatures where philosophy and truth and science intersect, Carl Sagan. I want to read what Carl Sagan wrote. And he says, look at that dot that I just showed you a minute ago. That's here, that's home, that's us. That's everyone you love, everyone you know, everyone you have ever, every human being ever lived out their lives. Unfortunately, I can't see this too well. Sorry about that. Every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived on that little blue dot suspended in a sunbeam. I think that encapsulates sort of our interest as humans to understand what's out there and also to be in the field of astrobiology. So the secret has always been for astrobiologists is what kind of life do we look for? Do we look for intelligent civilizations? Well, we have lots of sci-fi shows that tell us what intelligent beings would look like. And of course, we have SETI that actually looks for intelligent human beings. And we're actually, so SETI is a great institution, but it turns out to be very difficult to look for intelligent communication. It's like looking for a needle in a haystack, really, because there's only a very small part of our solar system or our universe or our galaxy that we can actually look at for radio signals. Now, SETI improved this by doing SETI at home. So they tried to use home computers and sort of a citizen science approach to make their search better, but it's still limited. So all of us in the astrobiology community felt like the best thing to do then would be to look for something simpler, not advanced life that had the technology that could get a signal here. So if Earth is 4.8 billion years old, and the first 2 billion years were dominated by microbes, there was nothing complex or multicellular at that time. It seems reasonable to us astrobiologists, whether you're a geologist or a biologist or atmosphere chemist, to think about how microbial life might affect a planet. And we inform ourselves by looking at how those microbes have affected this planet. And the first 2 billion years is a good place to look from our planet's perspective. Of course, that's what we're looking at is bacteria, which is mostly uninteresting, certainly not as interesting as ET. That's another example of bacteria. If any of you had strep throat, maybe this isn't the best slide with COVID these days. And then here is another slide of how microbial populations impact our oceans. So microbes are all over the planet, and that's what we've used as astrobiologists to consider what we need to look for on life on other planets, especially Mars, or in the past, the moon. These are some living stromatolites in a field site that I work in Mexico, all dominated by microbes as opposed to eukaryotic animals. Here's an example of a red tide. This, I think, is in Spain. Actually, not red tide, I'm sorry. It's a bacterial bloom in Spain. And then these are, of course, ancient stromatolites that are from Earth's early history that give us even more reason to think we should be looking for microbial populations or evidence of past microbial populations off Earth. So let's get real. The scientists from the University of Georgia estimate the number of bacteria on our planet to be 5 million trillion. That's 5 with 30 zeros after it. There are far more bacteria on Earth than there are stars in the universe. And the human body has more bacterial cells. Sorry, I cannot read these with this. Maybe I'll do this. 100 trillion bacterial cells, at least as many bacteria as actual cells in the body. So you are your bugs and you couldn't live without them. So the point of this is that we certainly have evolved as humans with this, as intelligent, sentient humans. We are part and parcel to that early history, that 2 billion-year-old history where microbes were the dominant form of life here on our Earth. So it's not going to do that. Sorry. So is life somewhere else going to look like what we see on Earth? Now that's sort of a conundrum that anytime you talk about looking for life elsewhere, we come to this. Are we going to recognize life when we see it? And I'm going to have a prejudice here that I'm going to show you. I've heard multiple different scenarios that could happen. Not saying that life is going to look exactly like life here as far as microbes, but I do believe that no matter where you are in the universe, the fact that we have the same toolbox, we have the same set of elements and chemistry to work with, that we're going to recognize it because of that atomic similarity. So the periodic table of the elements, no matter where you go, unless it's a planet that has, that for some reason doesn't have the sufficient periodic table of elements or doesn't have all of them, you're going to, life only has these sets of tools in order to make things work. So carbon is always going to be probably the best atom to actually make great connections with other elements. Phosphorus is a great element that stores lots and lots of energy. So whether or not you have DNA or RNA can be argued, but the fact that you'd probably use carbon as opposed to silicon, I would probably vote for carbon. So carbon-based Earth on life, you've probably seen this diagram similar to this. It uses these main elements across the board. And I think no matter where you go in our universe, this would probably be the tool set you would use. So let's just take a quick look after I've gone pretty fast over this. It's very difficult to do these Zoom meetings when you don't have an idea about how the audience is following. So forgive me if I've gone too fast. But let's take a look at this movie real quick.
The lonely, helpless Earth. 21st century. World of the future. And lurking beyond the cold, strange immensity of conquered space, growing and spreading beyond the warped imagination of the greatest human intellect, exploding in unspeakable horror, the green slime.
Okay, so that was just to sort of get us to the point where we're not looking for green slime for certain. That was a video of a science fiction movie from the 50s from the US. Might not be looking for green slime. I did think it was funny they date that movie to the 21st century, which is exactly where we are. And they make a comment that we've actually controlled space now, which we certainly have not. But like I said before, I do think that no matter what where our imagination might go, and what we're looking for as astrobiologists, all life, to me, my prejudice is it's likely going to use those elements that we see here. Okay. Of course, we could, I could be wrong. Maybe there could be something like ET or something different. but I'm sure Jim Casting went over this yesterday. We all, as astrobiologists, agree that life has to have something very particular. It has to have water, liquid water somehow. And when we're looking for life elsewhere, we have to find the planets that have the potential for liquid water. And again, I won't go over this too much because I'm fairly certain Jim covered this very well, but this is the meat to what we do as astrobiologists. We really and truly do hope that we have set our sights on the right prerequisites that are required for life to start on another planet, and water is the premier one. So how do we find these planets? Well, there's several ways we use it. We can use transit photometry, reflection emission modulations, relativistic beaming, ellipsoidal variations, pulsar timing, variable star timing, transit timing. If we were in a room together, I would be able to see your faces after reading those 7 or 8 ways we look for planets and be able to tell how many of you actually know any of those words. I can tell you I know almost none of them, but I do know this. Finding other planets turns out to be really, really hard. The main one that's used, and again, I'm sure Casting went over this really well, is transiting. And that basically is looking for a planet that is circling a star and bends the light curve just enough that you can see it with either a telescope that we have on the ground here on the Earth or in space. And that's how we found most of our extrasolar planets. Then the next step is to see if it's habitable. And of course, this is the classic Goldilocks dilemma. If you're too close to the sun and you don't have the right mass, you're going to be too hot. And if you're too big and you're too far away from the sun and you can't keep your planet warm, you're too cold. So if you're in the Goldilocks just right zone, then that puts you in the habitable zone and makes you more likely to have life that we might discover and have liquid water. So what determines liquid water on a planet? The kind of star, how far from the star, how heavy and rocky, the orbit, and the other planets around it. So this table, you don't need to really know too much about it. And this table is at least 1.5 years old. And so it's actually already out of date from the extrasolar planets that have been discovered since then. And I read yesterday that another extrasolar planet outside of our galaxy has been discovered. But the bottom line to all of this is that none of these so far have the same kind of sun that we do. Our solar system has some anomalies that are hard to understand regarding extrapolating to what we've observed so far in other planets that we think could harbor life. And then ET has not phoned home. So we're a little bit stuck because our technology hampers us. So when I say that, here is an example of how our technology hampers us. If we were to get some sort of intelligent communication from another civilization, turns out it would be as slow as a sloth. Even if aliens are sending messages, it would be a really slow conversation. So up to now, we have focused on life elsewhere, and we've based that search using Earth-based observations or things that we have sent out into space to actually observe. We've actually, as astrobiologists, have a huge, huge problem because I don't think anybody thinks, unless we have some sort of unusual technological advances that we can't foresee, nobody in the next 5 or 6 generations will be able to even remotely visit one of those extrasolar planets. But something has changed in the last, it started changing about 15 years ago, but it is really ramped up in the last 5 years. And that is that we are actually, as a global community headed into space as colonizers. That makes the field of astrobiology more relevant than it's ever been. So in 1958, an Air Force general said the following: "He who controls the moon controls the earth. Our planners must carefully evaluate this statement, for if true, and I for one think it is, then the US must control the moon." Now I bring that up because in the 50s and the early 60s, that's when the space race started. And it was predominantly between the US and Russia. But that has changed now. So just for a second, let's revisit where that space race took us.
Very, very fine grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the limb. That's one small step for man, one giant leap for mankind. Oh, that looks beautiful from here. It has a such beauty all its own.
Okay, so what Neil Armstrong said there turns out to be very, very prophetic for today, because even though that was the US and it was predominantly a race between Russia and the US set up politically, now we know that all of the colonization and all the movement out into space is a global opportunity these days. I remember watching that movie with my dad, or watching that broadcast with my father, and it was just as blurry back then as it is there in that recording. Just how incredible that was. And I think because we see so much science fiction and we see so many people, are the movie industry is so good about showing us space that are not real pictures, we don't realize how phenomenal that event was and what a step it was for mankind. So even though I can't get any kind of feedback from any of you, I thought this little pop quiz, which I'll answer for you, was interesting. So I don't know if you can imagine, some of you that are listening today probably one day will be on the moon. And here in 1960, so almost 65 years ago, Armstrong and Aldrin did their work, did whatever it was they needed to do, and then they went to sleep on the moon for the night and came back the next day. I thought that was sort of just an interesting personal event for them. So they worked and then they slept on the moon. Do you know how many people have been to the moon? What countries have sent men to the moon? You might be surprised at those answers. How long does it take to get to the moon? In a rocket, it takes at least 3 days. And that is a picture of a Russian piece of the moon that they brought back. But along with all of this change that I'm trying to talk to you about, there's been a change in space explorers as well. So from 1969 to 1921, we've had women go into space. And then, of course, we've had businessmen go into space. So not only as astrobiologists do I think that our ability to contribute to what's happening as far as the Earth community exploring space, it's just a much broader, more inclusive group of people that get to participate. So this is what I think is going to happen in the next 10 years or so. There are going to be moon bases that will be established on the moon. China, India, the US are all participating in different scenarios that will allow this to happen. Now, one needs to ask, well, why should we do that? we probably should ask who is doing it, and we should probably ask where are we going to do that on the moon and how. So this is the International Space Station. If I was in the room with you, I would ask you to actually tell me why you think we are going to the moon to colonize it. There's great innovation that has come out of our space research so far. For instance, ceramic coatings in our kitchen, air purification systems, smoke detectors, scratch-resistant glass. The French astronaut Thomas Pesquet on the ISS tested materials designed to prevent bacterial growth, which turns out to be important in a lot of reasons. We understand osteoporosis better. Water consumed on the ISS is through urine, and it's recycled. Water's a big deal on our planet. So just this kind of technology has been part of the reason why exploration is being fueled. But let's all be honest, what usually drives the why we're doing anything as humans? The moon has iron, titanium, aluminum, silicon, calcium, and magnesium. Mars has iron, titanium, nickel, aluminum, sulfur, chlorine, and calcium, and silicon dioxide. Asteroids, iron, nickel, iridium, palladium, platinum, gold, and magnesium. Certain asteroids have pure metals in great quantities, and the asteroid belt could be worth $700 quintillion. I have no clue what that means. That sounds like a lot of money to me, though. And there's water. And that's the asteroid belt that we're talking about. So let's just be honest, even as astrobiologists who want to do something that contributes to the science of astrobiology, what's driving most of this exploration is actually money. So who's in the race these days? So China, they've already landed on the dark side of the moon. This is an actual panoramic photograph of their landing. There's possibility for helium-3, which would fuel fusion reactors. And in the 2020s, they're going to have a complex and successful orbiting, landing, and returning vehicle. India turns out to be a huge agency that the agency actually puts lots and lots of satellites up. So 342 satellites for 36 different countries as of February 28th in 2021. And this picture shows when they began, I mean, they were just carrying rockets and rocket parts on the back of bicycles and on ox carts. So what does this have to do with astrobiologists? Well, I think it has maybe everything, because nowadays it's an internet-driven and global approach to space. We have commercial versus government space programs. So now no longer is it, or will it ever be again, a race just between two countries. So where are they going to go on the moon? Well, this is just not just on the moon, but on any kind of body outside of Earth. This is just a quick review of some of the places that we've actually landed and some of the countries that have been. So it's been Japan, US, the European Space Agency, China, everything from landing on the moon's far side, first spacecraft to fly by Pluto, first spacecraft to land on a comet. I mean, it's a vibrant exploration that's actually going on. So what's coming? Do we cooperate with the commercialism? So in the United States, you have NASA, you have Blue Origin, Dynetics, and our SpaceX could be working with NASA. You have human landing systems. The first private company to safely land American astronauts on the moon in 2024 is actually in the works. Russia is working with China and their International Lunar Research Station. And China is also working on a development of a Mars sample return mission and a Jupiter probe for launches around 2028 and 2030. Human spaceflight, they're constructing 3-module space station by the end of 2022. India, they're still sending lots of satellites. They have historic first spacefarers to orbit in 2021 and a rover on the moon in 2022. So what about Brazil? So it turns out that Brazil's actually in the mix as well. So in a cooperative agreement with India, they launched the Amazonia 1 satellite. This was in February of this year. And in order to do these launches, you have to be able to have this rocketry, which when I started looking into this talk, I did not appreciate what it means to actually have rockets that can do some of the things that we're doing. To get to the moon, you have to have these rockets that SpaceX and all of them are developing as commercial entities to be able to do some of the work they're doing. They're some of the most powerful rockets outside of the ones that took us to the moon. The other interesting facet of this moon colonization issue is that we're likely to be going to use some of the geology that went on the moon that created basically lava tubes like you might find in Hawaii. So the first colonizations might take advantage of these basically lava caves on the moon. So Brazil is playing a part in this moon colonization. I think it was in July of this year, Brazil's space agency joined NASA's Artemis moon mission. So what does this have to do with us as astrobiologists? Let's change gears just a little bit and go back to the philosophy. There's an interesting moral obligation here. The first thing is, just thinking about it from my own opinion, there is a race, but it's a global race to the economic benefit of traveling and colonizing space, the moon, or going to asteroids or to Mars. And that puts us back into a place where we were when we were discovering different parts of our Earth. So the moral obligation is that lawyers actually have to be involved and government agencies have to be involved, because who owns the moon? Who has the jurisdiction on the moon to dictate who can or cannot drill in a certain place, or who owns it, or who can't go there? We certainly, I'd hate to think that history would repeat itself. So we have to be forward thinking about these kind of obligations. As I said, who owns our moon? And it is our moon. It's Brazil's moon, it's the US's moon, it's India's, it's Africa's, it's everybody's moon. And so we have to think thoughtfully about how to proceed. As astrobiologists, I think we have a role of helping to inform that part of our communities, the legal communities, the government communities, to help inform how that should be thought of. When they first set foot on the moon, there's a plaque there that says that they left there that says, "Here men from the planet Earth first set foot on the moon. We came in peace for all mankind." I actually do hope we do better and that is true as we move forward. But then what is the future for Brazilian astrobiologists in all of this? Well, I think it's everything. I think that you are uniquely in a place where you don't have to be from a certain country to participate. You don't have to have a certain, actually, the premier thing to me is you're trained across disciplines as an astrobiologist. You're actually someone who can speak to some, if they're outside your discipline, you can actually speak to them if they're in a different discipline because you're used to that. That's what astrobiologists are really good at doing. That's what we've been trained to do. And I think the world's wide open for astrobiologists. So my encouragement to anybody that's listening to this is that make the most use of your education, of speaking with other people as your education proceeds, and don't be afraid to try and insinuate yourself in any kind of program. Since this is a global cooperative set of goals, make use of trying to find places where you can be a participant, whether it's in the US or if it's in India or in your own in Brazil. Make yourself known, because I can promise you somebody that's listening to this today, in 20 years, you will have gone to the moon. And maybe some of you will have gone to Mars. I find that extraordinary. And I think you should take advantage of every opportunity you have now, because there's never been a time like this in science's history. Okay. Hello?
Okay, Janet,
Yes.
are you finished?
Yes. I didn't know how to end that. So I just
was a bit sudden, but it's okay. Well, thank you very much, Janet, for such a nice and for passing on to us a bright and optimistic vision, not only about mankind, but about the profession of astrobiology. And you are painting to us a world in which this multidisciplinary approach from young scientists is going to pay off in many different ways. I find this really encouraging, really heartening. So what she's saying, take heart.
Yes.
If you really envision yourself as an astrobiologist, as a multidisciplinary scientist, now is the perfect time.
Exactly.
Because of different cooperative and global enterprises that are popping up everywhere. And Brazil may have a part to play in this. So thank you very much, because I'm always worried as a teacher about the vision of young people. And I'm always trying to pass on to them optimistic outlooks of life, because this is what they need the most, I think. We haven't actually gone through a pandemic. We are still going through the pandemics. And this has been a really hard time for everyone, especially young people. I really worry about young people. You must be optimistic. You have no other option, because you have this whole life to live. And so optimism is the only option. So thank you very much for bringing up this to us. Okay, so we can start to take questions. Janet, and I think Claudia may have a comment.
Mm-hmm.
Okay, go ahead.
Hello, Janet.
Hi.
How are you?
Good. How are you doing?
Nice to meet you under such crisis, because we are just one click away, one from another.
Yes.
Click, click. Oh, very nice your point, Janet, because I think astrobiology is quite a science in the horizon of knowledge. And I really appreciate your final words regarding the message we are committed to pass to our young scientists.
Yes.
Because in Brazil, particularly, we're going through a very difficult moment for this period. But thank you. I would like just to really say that I appreciated your talk because of this future the vision of the future and the importance of this message. Thank you very much.
My pleasure. I believe it too.
Okay, so we can begin to take questions. Anyone feel free. Someone from the panelists, would you like to ask a question? I have a couple of questions myself, but I'm waiting until you step forward.
Gustavo.
Okay, Marcelo?
I have one. Hi, Janet. Thank you for this nice talk. Okay, can you hear me?
Yes, I can.
Okay, great. So my question, I think, I don't know if it's simple or not, but from the biologist's point of view, do you think that we can really, for example, send a mission to Mars in the next few years, even considering the problems that we have in terms of technology, especially concerning the problems related to radiation, for example, to put some astronauts living there for some months or even longer? Do you think that we can solve these problems in a short time scale? I don't know.
Well, I mean, the only answer I can give you is just a guess, because I'm not up on all the missions, or I certainly don't know all the technology behind all the missions. But I've been totally surprised at how fast things are moving. So do I think it'll happen in 3 or 4 years? No. But do I think something will happen in 10 years? I think so. I mean, I don't know if I don't know what human beings would go. I don't know who it is that would be willing to do it. I hope it's none of my sons or grandchildren that want to do it. But I mean, I think there are people that would do that. I mean, I just cannot believe how, I mean, China's already on the dark side of the moon. I mean, they've already landed there. They've already done things. I mean, I think it's possible. I do. In 10 years or so, I do. Do you?
I hope so.
I mean, the fact that we can land on an asteroid and take samples, and then we've done that. I mean, I don't even, that boggles my mind. I mean, I don't even know how we're capable of doing that, but we've done that. You know, I don't even know how you think about the whole business side of this, where it's worth it to fly to an asteroid and mine something and bring it back. I don't know how that business model works, but clearly I'm not privy to the same things that people that are trying to do that know how to do. So I would, if you had asked me, I remember sitting in a meeting probably 15 or 16 years ago, and somebody brought up the moon, and somebody said, no, we're never going to go back to the moon. We've been there already. And within that short of amount of time, I mean, in the next 4 or 5 years, there'll be more people on the moon. So that's the feeling I get here in the US for sure.
Okay,
I think we could also recall that India got to Mars in their first attempt. They sent a probe around Mars, an orbital probe. China landed in their first attempt. Japan has been to comets, to asteroids. Israel went to the moon. They crashed, but they got there.
Yeah.
And so we are really looking at a tremendously multipolar, multi-country effort in all fronts. I'm sure there will be competition with cooperation, just like there was in the first space race, in the Cold War. There was a certain amount of cooperation as well.
Yeah.
After all, we are all in the same boat, and I think the rationality is bound to prevail. I'm a son of the Cold War. I was born under the fear of total nuclear war. I'm 56 years old. I was scared, and rationality prevailed. And I'm always betting on human rationality. So that's a personal view on this. And any more questions from the panelists?
I think we can go to the YouTube question, sorry.
Not just yet, Marcelo, please. I would like to go back to the fundamentals then, because
Okay.
we had this this view from Mario de Pina in the morning lecture, and he more or less he showed us a kind of optimistic view about the possibilities for the diversity of life in its building blocks and energy strategies and so. And you more or less, you repeated the view from Jim Casting that you certainly seem to think that carbon and water are special. And I was raised as an astrobiologist in this competing view between optimists and the pessimists. And I've always sided myself when I became really an adult with the pessimists that we see that carbon and water maybe are special. So would like to elaborate perhaps a bit more on this view that carbon and water might be irreplaceable or something like that.
Well, I mean, I've heard Steve Benner, he's talked about alternative solutes for the way you're going to do biochemistry. People have talked about silicon life, you know. I have to admit, I mean, I can't, those particular elements are just so good at what they're doing. And again, because it's clear to us that all of life here has sort of stemmed from one giant plan which used those elements. It's hard to think outside that box, but there's nothing else that really works as good as water. I just, to me, it just makes sense. It just seems logical. Of all of the elements there, you would have thought something might have replaced, you know, if we've been evolving for 4.8 billion years, you would have thought at some point there would have, if something worked better, I don't know, once you get too far along the evolutionary lines, it's hard to, you know, it's hard to substitute something, but I just think it's just too good. They're just elements that do exactly what we need to do.
So you could say that you believe in, say, variation within the same toolbox rather than giant dissimilarities between the architecture of life.
Yeah, so I actually think that the variation, I mean, as I've gotten older, the variation on this planet as far as biology goes astounds me. And how that in only 4 billion years can happen, I don't really know. And I do have a sense that evolution works in a way that once it gets down sort of a pathway, there's only so much diversification it can make. It can't, I mean, it can do some extraordinary things, don't get me wrong, but it can't, it's kind of like, you just can't go backwards in evolution. You just keep moving forward, and maybe your options are a little bit narrower and narrower. But the astounding diversity on this planet, everything from microbes to giant trees and everything else, I just think that's a testament to how powerful evolution is as a process using a small toolbox, a small good toolbox. You know, if I want to make a car, I could try to make a car that used different kinds of maybe wheels that were square or something. I don't know, but I mean, a car is the best car when it has a round wheel. So I think
really can't come up with something too different from this.
Yeah, I can't. But that doesn't mean that there isn't. That's why I caveated that with saying this was my prejudice. It is my prejudice. But I, you know, even listening to some really smart people, I don't know. I still hold the prejudice.
Oh, we acknowledge James Casting as a panelist. Hi, Jim, you would like to ask a question for Janet? You have the floor. I think you're muted. We can't hear you. Jim? You're muted. You're muted.
Oh, sorry.
Oh, okay, now. Start over, please.
I did talk about liquid water yesterday, and I agree with what you said about it, Janet. So, but you know, my talk was specifically on searching for life on planets around other stars. And what I tried to say, I hope I said, is that I just don't think we would recognize life on an exoplanet unless that exoplanet was in the liquid water habitable zone. So in our own solar system, we can go look for life in Titan's methane lakes, and there are people that want to do that. I don't think they're going to have success, but that's a testable hypothesis. But for exoplanets, I think we should focus on water-based life.
Okay. Thank you, Jim. And Marcelo, perhaps you could go now to the YouTube questions if no one from the panelists has another question.
Yes, let's see, Raquel, Luis, Vinicius.
Hello.
Okay.
Do you have questions there?
Yeah, we have two for now. So, hello, Janet. Thank you very much for the lecture. It was really informative. It's one of the topics that I'm really interested in. I don't exactly study it on my master's, but I like to read about it, and it was a great talk. So the first question comes from Mariana Navia, and they ask, I get that bacteria is the first step when trying to find life elsewhere. But if we manage to detect a virus from another planet, would this still count?
Well, that's a great question. The only way we understand viruses is that they are not getting into the definition of what's alive and what's not alive, but we don't consider viruses as being alive. So they don't have any kind of mechanical way of like crawling around or getting up your nose or anything. So viruses just literally are at the whim of wind and physical constraints, and they have to have a host. So I don't know what it would mean if you just, the only way I can think about a virus is a virus the way we understand them here. And I can't imagine an Earth kind of virus living on another planet for any length of time, or for even finding some way to, I mean, viruses don't have any way of encapsulating themselves to protect them from being dehydrated or anything. So if we did find a virus on another planet, we'd have to really rethink about what we think about viruses. That's a great question, though. Did you have a follow-up?
No, that was it. Thank you.
Okay.
Hi, Janet. Thank you so much for your talk. It was amazing. I have another question from the YouTube chat. It's from Ricardo Oliveira, and he's asking, in the search for life on exoplanets, the slogan is follow the water. Do you think that exoplanets with methane or liquid anomalies, is it possible to develop life, or is the very low temperature too bad for life?
Ooh, well, as a biologist, I mean, we have things that handle methane. We have bacteria that handle methane and low temperatures. But Jim, if Jim's still on here, he may want to answer that question. Is Jim still on the panel?
Yes.
I'm here. I think I brought up the liquid methane, but there's problems with activation energies at those low temperatures that, you know, you have to have metabolisms that run at a certain rate to be able to just repair damage from oxidants and cosmic rays and things like that. And I'm not a biologist like Janet, but I suspect that life doesn't work at 90 Kelvin or whatever.
Yeah, it would be very hard. Thank you. I think that's all. We had only 2 questions from YouTube.
We have no more questions from YouTube. Raquel, Vinicius?
No, only Diogo Souto said it was such a great talk.
Any of the other panelists would like to add or ask something? Come on, guys.
I tell you, I really dislike Zoom conferences. It's just so hard.
It's really difficult, yeah.
Yeah. Well, you just
We have
can't.
come a long way.
Yeah, you don't know where to stop and where to slow down and where to explain something better. But y'all did a great job hosting this. I mean, it went off flawlessly, so that's good.
Marcelo, would you like to add something or ask a question?
No, I would like just to say thank you so much again to Janet, to Jean, to Adriana, and also Mario for the great talks. So it was really great to have you here for the Astrobio Online, and I would like to invite you for next year, hopefully in our traditional face-to-face edition here in Rio. So you are already invited to be here next year, please.
Yeah, we were already both invited. We were planning all along to perform a real face-to-face meeting. So we came up with this partial solution, but the invitation stands for all of you. If everything turns out in the best possible way, we're going to have a face-to-face meeting, a face-to-face school.
Yeah.
And please, you are invited. Consider yourselves already invited.
Yes.
In 1 year's time.
Yeah.
So here's to 2022.
Yes.
By all means.
And I would like to say thank you to everybody watching us here. So it was great to have you also here. So thank you.
Thank you, Jim. Thank you, Janet. Really.
Thank y'all.
Bye-bye.
Thank you, Jean. Thank you, Janet. So see you next year.
Yes. Bye-bye. Y'all have a good week.
Okay. Thank you all.